Ever wonder how metals transform from solid to liquid? In today's video, we're going to break down everything you need to know about the melting point of stainless steel. Information that every metal worker, engineer, and DIY enthusiast should know. This knowledge can save you from costly mistakes on your next project. Welcome back to Metals 101, your go-to source for everything metal-related. If you're new here, make sure to hit that subscribe button and turn on notifications so you never miss out on expert metalworking tips and advice. Let's talk about what the melting point is. It's the temperature at which a solid becomes a liquid. You probably learned this back in school when you explored how ice melts at 32 degrees Fahrenheit, 0 degrees Celsius. But unlike water, metals like stainless steel have much higher melting points, and not all grades of metal melt at the same temperature. For stainless steel, the melting point falls between 2,550 degrees Fahrenheit and 2,790 degrees Fahrenheit, 1,400 degrees Celsius to 1,530 degrees Celsius. This isn't a fixed number because stainless steel is an alloy, which means it's made from several elements. Alloys melt over a range of temperatures because each element has its own melting point, and when combined, the melting point can shift. This is called melting point depression. Steel, for example, is primarily made up of iron and carbon. When you add chromium, nickel, and other elements to create stainless steel, you lower the overall melting point. The more elements in the mix, the lower the melting point becomes. But why should you care about stainless steel's melting point? If you work in an environment with high heat, like metal fabrication or casting, understanding this could be the difference between crafting a perfect piece and turning your materials into a molten mess. Steelworkers rely on this knowledge to get the temperature just right, whether they're creating structural supports or components for things like kitchen appliances or medical equipment. Melting and casting stainless steel correctly ensures the product is strong and reliable. Researchers use something called the melting point determination principle to pinpoint the exact melting point of an alloy. They test stainless steel using a technique called the capillary method. A small sample is placed in a tube, heated next to a precise thermometer, and the temperature is gradually increased by 1 degree Celsius per minute until the metal liquefies. The moment it becomes fully liquid is recorded as its melting point. So, what does this mean in terms of actual temperatures? Steel melts between 2,500 to 2,800 degrees Fahrenheit, 1,371 to 1,540 degrees Celsius. But when you add elements like chromium and nickel, as with stainless steel, the melting point falls into a slightly lower range, 2,550 to 2,790 degrees Fahrenheit, 1,400 to 1,530 degrees Celsius. Different grades of stainless steel have different melting points. For example, grade 316 stainless steel melts at 1,375 degrees Celsius, while grade 430 stainless steel can withstand temperatures as high as 1,510 degrees Celsius. The most common grade, 304 stainless steel, has a melting point of 1,400 to 1,450 degrees Celsius. So why does this matter to you? The tensile strength of stainless steel changes at high temperatures. Around 1,000 degrees Celsius, stainless steel can become more flexible, which could impact projects where strength is critical. If you're designing something like a metal basket that needs to carry heavy loads in extreme heat, understanding how temperature affects its strength is crucial. At 800 degrees Celsius, that basket might carry twice as much weight as it could at 1,000 degrees Celsius. Not only that, but the melting point also influences stainless steel's resistance to oxidation and sulfurization. Stainless steel usually resists rust thanks to its chromium content. But when you heat it up, the nickel, which has a lower melting point, can weaken the protective effect of chromium, leaving the iron in the steel more vulnerable to oxygen and sulfur damage. In short, knowing the melting point of stainless steel is essential when selecting the right materials or choosing the correct fabrication techniques. If you learned something new today, make sure to give this video a thumbs up and subscribe to Metals 101 for more in-depth tips and tricks on working with metals. And if you have any questions or want us to cover a specific topic in the future, drop them in the comments below. Thanks for watching, and we'll see you in the next video.